Welcome back to our channel. This is Make Me Smile. The world of the Space Shuttle, the first reusable spacecraft that revolutionized space exploration. This shot will give you an overview of the video and its agenda, everything from assembly, launching, and landing. This video will be followed by brief narrations about the history of the Space Shuttle, its purpose, and its impact.
10, 9, 8, 6, 5, 4, 3, 2, 1.
As always, we strive to bring you the most comprehensive and compelling content possible. So buckle up, as we embark on an incredible journey beyond Earth's atmosphere. Our magnificent Earth not only boasts diverse landscapes but also hosts a myriad of ecosystems, each intricately woven into the fabric of life. From the depths of the oceans to the heights of towering mountains, every corner of our planet whispers tales of resilience, biodiversity, and the remarkable cycles that sustain life. Have you ever wondered why humanity is so driven to manufacture space rockets? The answer lies in our insatiable curiosity, the desire to explore the unknown, and the pursuit of knowledge. Join us as we explore the compelling reasons behind the creation of these incredible machines. Now, let's rewind the cosmic clock and revisit the historic moment when the idea of reaching for the stars became a reality, the first space rocket and its creator. Our journey begins with the historic V-2 rocket, the world's first long-range guided ballistic missile, and the precursor to space rockets. Developed during World War II by German engineer Wernher von Braun, the V-2 laid the foundation for future space exploration. 1942, Wernher von Braun and Walter Dornberger launched the first V-2 rocket at Peenemünde in northern Germany.
Another launching for the great weapon.
1942, a V-2 rocket reaches an altitude of 85 kilometers. 1944, the V-2 rocket MW-18014 reaches an altitude of 176 kilometers, becoming the first man-made object in space. Wernher von Braun said, "In my pursuit of knowledge, I dreamt of reaching the stars." The V-2 was the first step, a bridge between warfare and the cosmos. Little did I know, it would pave the way for the space age. This image could have imperfections as it's either historical or reportage. Wernher von Braun had injured his arm in escaping from advancing Russian forces before fleeing to Austria, where he was captured by an American unit, along with Walter Dornberger wearing hat. Antenna. The antenna receives and transmits radio signals for missile tracking. Thrust vanes. Small devices called vanes were placed in the rocket's exhaust to deflect thrust. Engine. During combustion, this area reached temperatures between 4,532 to 4,892 degrees Fahrenheit, 2,500 to 2,700 degrees Celsius. Stabilizing fins. The rocket's fins had a wingspan of 3.56 meters. Hydrogen peroxide container. Fuel and liquid oxygen pumps were powered by a steam turbine. Concentrated hydrogen peroxide produced this steam, liquid oxygen tank. For the fuel to burn quickly and under pressure, it was combined with liquid oxygen, suction line. This line delivers the liquid propellant to the rocket engine, fuel tank. This tank held a mixture of 75% alcohol and 25% water. Missile control. A device called a gyroscope senses the acceleration and angle of the rocket to guide it towards its target, warhead. The rocket warhead contained 738 kilograms of explosives. For more information about the V-2 rocket, you can visit the Smithsonian National Air and Space Museum website. Additionally, you can learn more about Wernher von Braun by reading NASA's biography. National Air and Space Museum, location. The main location is on the National Mall in Washington, D.C. There is also the Stephen F. Udvar-Hazy Center in Chantilly, Virginia, educational programs. The museum offers educational programs for students and educators, including workshops, lectures, and outreach initiatives, online resources. The website provides online access to a vast array of resources, including virtual exhibits, educational materials, and research tools. Wernher von Braun, Dr. Wernher von Braun, 1912 to 1977, was one of the most important rocket developers and champions of space exploration in the 20th century. As a youth, he became enamored with the possibilities of space exploration by reading the work of Hermann Oberth, whose 1923 book The Rocket into Interplanetary Space prompted von Braun to master calculus and trigonometry so he could understand the physics of rocketry. From the Main University in Berlin. Von Braun was a member of an SS equestrian unit in 1933–34, joined the Nazi Party in 1937 and became a junior SS officer in 1940. Dr. von Braun was among a famous group of rocket experimenters in Germany in the 1930s. He is shown second from the right in this photo, NASA/MSFC. From his teenage years, von Braun had held a keen interest in space flight, becoming involved in the German Society for Space Travel, VFR, in 1928. As a means of furthering his desire to build large and capable rockets, in late 1932 he went to work for the German Army to develop liquid fuel missiles. Based on his Army-funded research on liquid propellant rocketry, von Braun received a doctorate in physics on July 27, 1934. In 1960, President Eisenhower transferred his rocket development group at Redstone Arsenal from the Army to the newly established National Aeronautics and Space Administration, NASA. Its primary objective was to develop giant Saturn rockets. Accordingly, von Braun became director of NASA's Marshall Space Flight Center and the chief architect of the Saturn V launch vehicle, the superbooster that would propel Americans to the moon. Now, we're going to be talking about the amazing process of rocket manufacturing to launching. As promised, I'm going to take you on a journey through step by step. The design phase. The design phase is the first and most crucial stage in the rocket manufacturing process. Engineers and rocket scientists work together to create blueprints and designs that will ensure the overall success of the mission. The design of a rocket is critical to its performance, and every single detail must be taken into account. The design phase of a rocket is of utmost importance as it sets the foundation for the rest of the manufacturing process. A meticulously crafted design will ensure that the rocket is capable of meeting the performance requirements and carrying out the mission in a successful manner. During this phase, engineers and rocket scientists collaborate to conceptualize the design and transform it. The design must undergo rigorous testing, analysis, and evaluations to ensure that it meets all the necessary safety, reliability, and performance parameters. The design phase is where every single aspect of the rocket, including the materials used, the fuel systems, the communications equipment and the guidance systems. The manufacturing phase. Once the design is finalized, the manufacturing phase begins. This is where the rocket comes to life.
Off of Space Shuttle Atlantis, reaching the crest.
The rocket is assembled in sections, each with its own set of components. These sections are then assembled together to create the final product. This is a time-consuming and delicate process, and every step must be completed with precision. The rocket is assembled in sections, with each section having its own set of components. These sections are then carefully assembled together to create the final product. During this process, engineers and technicians work with exacting precision, making sure that every step is completed correctly. Creating a rocket is a time-consuming and delicate process, and every step must be completed with precision. From the smallest bolt to the largest engine, each part plays an essential role in the success of the launch. This is why the manufacturing phase is so important, and why every step must be handled with the utmost care. When it's all said and done, the result is a remarkable feat of engineering and human ingenuity that represents the pinnacle of technological achievement. It all begins with a spark of genius and a vision to explore the vast cosmos. Engineers and designers work tirelessly to conceptualize a rocket that not only meets the mission requirements but also pushes the boundaries of what is possible. This stage involves intense brainstorming sessions, where ideas are shared and refined until a unique design emerges. Engineers opt for lightweight yet robust materials like carbon composites and advanced alloys to maximize the rocket's performance. At this stage, precision manufacturing techniques come into play, guaranteeing each component's utmost quality. The heartbeat of any space rocket lies within its propulsion system. In this section, we'll delve into the awe-inspiring world of rocket engines. Engineers meticulously design and assemble powerful engines capable of producing unimaginable thrust. And there you have it, the awe-inspiring process of space rocket manufacturing, where human ingenuity and technological prowess converge. From the conceptualization and design phase to painstaking material selection, manufacturing safety is the golden rule in space exploration, and to ensure it, rigorous quality assurance and testing procedures are essential. The testing phase, before the rocket can be launched, it must pass through a rigorous testing phase. This is where engineers will test the rocket's functionality, safety, and overall stability. Any issues found during this phase must be addressed before the rocket can be cleared for launch. Experts scrutinize every nut, bolt, and connection, conducting meticulous inspections and non-destructive testing techniques. Rocket parts are subjected to extreme conditions, simulating the harsh reality of space to detect any potential weaknesses. Numerous simulations and test launches are conducted, culminating in a final countdown where the rocket's every system is critically evaluated before granting it the green light for the ultimate journey. Engineers will closely monitor the rocket's trajectory and flight simulations to assess its overall stability and accuracy. The data collected during these tests is meticulously analyzed to ensure that the rocket meets the highest standards of safety and performance. Once all issues have been addressed and the rocket successfully passes the testing phase, it can proceed to the final step before launch, validation.
8, 7, 6.
And there you have it, the awe-inspiring process of space rocket manufacturing, where human ingenuity and technological prowess converge. From the conceptualization and design phase to painstaking material selection, manufacturing. Join us in our next adventure with Space Rocket Launch Phase. Don't forget to subscribe, hit that notification bell, and stay curious. Until next time, keep dreaming big and reaching for the stars.